Cinder, a type system for Python. Greetings all. Today we're diving into a deep dive on how Cinder JIT compiler represents types. It's quite fascinating because they approach it as sets, which are essentially lattices, an incredibly compact way of representing data with operations that must be fast. They start from first principles and build their way up to what Cinder has in mind, but also introduce some new concepts like specialization for tracking specific objects rather than just types. This kind of representation is neat because we can perform set operations instead of basic bitwise ones, which makes the whole thing more intuitive yet equally compact. The piece reveals that representing type lattices compactly allows the compiler to create and manipulate types with abandon, making all operations fast, even for infinite sets like lists. They then proceed from first principles using Python code snippets as intermediate representation. I found it particularly interesting when they discuss their bit set representation of different built-in types, in which each bit in a number indicates whether the type is present or not. This approach is useful because you can use bitwise arithmetic to encode other sets into your basic set, and also because checking if one type is a subset of another involves simply looking at where they overlap. One thing that stood out was their introduction of specialization, keeping track of specific objects rather than just types. They have what's referred to as a specialization lattice, which represents the exact object within the set it refers to, making optimizing certain operations much simpler and efficient by reducing precision loss in identifying possible type discrepancies, such as lists or strings with len, methods that directly access size fields on objects instead of performing generic calls. Overall, this is an impressive piece showing how powerful representation can be when dealing with complex data structures, like types, a lesson for all programmers.